Lesson 23, workbook examples, question 6. Suppose 7 people are waiting in a room for job interviews. The people will be taken to their interviews in groups of 4. A. Which expression correctly shows how many ways 7 people can be placed into a group of 4 people? And B. Evaluate the expression you chose in part A. So first question, is this a combination or is it a permutation? And because it's not saying that you have to be in a first, second, third, or fourth position, and it's just lumping them. So you 4 all together. It doesn't matter how I picked them, they all ended up in that same group. It's a combination. So combination, the order doesn't matter. And then they want our expression. So they want the longhand notation. So we need to know what is N and what is R. Well, N is our total number, that's 7, and R is how many we could choose. That would be 4. So we would have 7 total and we're choosing 4, and that's going to equal 7 factorial times our R, so 4 factorial, and then whatever is left over, so 7 minus R, so 7 minus 4 factorial, and we have 7 factorial divided by 4 factorial, and 7 minus 4 factorial is 3 factorial. And if you notice this, 4 and 3 added together make a 7, and so that's how I remember my combination is in this subtraction part, I know that I'm taking my total number and subtracting my groups, because this is the number of groups that are still left. And so we can use our calculator for this, and since the denominator has 4 factorial and 3 factorial, we're going to include parentheses when we type that into our calculator. So we are going to have 7 factorial divided by parentheses 4 factorial, 3 factorial. That's going to equal 35. Okay. So we have 7 factorial divided by 4 factorial times 7 minus 4 factorial, and that gives us 35 groups. Great job. Alright, so question 5. Suppose 15 job applicants are waiting in a room for their interviews. A group of 4 people are taken in for their interviews. A. Which expression correctly shows how many ways the applicants can be placed into groups of 4? And B. Evaluate the expression. So the question I'm going to start asking myself is this a combination or is it a permutation? Does it matter which people I choose? Does it matter if I chose Anna first or if I chose Anna last? Does it matter to her? And that's a no, because she's still ending up in that one group, whether she's chosen first or last. So that's a combination, versus if Anna goes first in a race, that's first place, versus if she's last in a race, that's last place. So that would matter to Anna. That makes a difference. So that would be a permutation. So in this case, they're lumping them into groups. And it is a combination because it doesn't matter if that group you were chosen first or chosen last, you still ended in that group. So it's a combination, and we have 15 people, and we are going to take 4 of them at a time. So we're going to have 15 choose 4, and that's going to equal 15 factorial, the total number of ways I could pick 15 people, and then we're going to divide out the 4 factorial. The 4 is how many ways I could arrange those 4 people, and then what is left over from 15 and 4. So 15 minus 4. And this is how many other ways my leftover groups could be picked. So that's going to equal 15 factorial divided by 4 factorial times 11 factorial. And since we have 4 factorial and 11 factorial in the denominator, we are including parentheses around it. So we have 15 factorial divided by parentheses 4 factorial times 11 factorial. That's going to equal 1,365. So that equals 1,365. Okay, so for A we have 15 factorial divided by 4 factorial times 15 minus 4 factorial. And then for B we have 1,365. Great job. Okay, so question 4. Read each of the following situations in order to determine if it is a permutation or a combination, then follow the instructions. Okay, well, I'm going to jump to the instructions. Select 4 answer choices, 1 for A, 1 for B, 1 for C, and 1 for D. Okay. Choosing 3 winners in a lottery to receive identical prizes. Okay, since the prizes are identical, that wouldn't matter which way those 3 winners were chosen, because the prizes are going to be the same whether you're chosen first, second, or third. So situation A is a combination. And then selecting 5 books out of 12 to take on vacation. It's not saying which one you're going to read first or which one you're going to read second. It's just saying pick those 5 books or choose those 5 books out of those 12. So situation B is a combination. And then arranging 25 different books on a shelf. This one, order would matter, because whether you put a book on there first makes a difference, because it ends up in the front. So to me, situation C is a permutation. And then deciding on an order for second, third period to take English, math, or science classes. This one matters because you're assigning it. It says in order. There's a key word from our permutation lesson. Order first, second, third for English, math, and science. So it does make a difference which one you pick first. So situation D is a permutation. So in my notes, I would write, again, permutation, order is a keyword. Another keyword for permutation is arranging. So what is a keyword for a combination? Keyword for combination would be selecting or choosing and identical prizes. So those would be my keywords that I would write in my list for my permutation and combination. Great job. All right. Question 3. Read each of the following situations in order to determine if it is a permutation or a combination. Then follow the instructions. Alright, so the instructions are select 4 answer choices, 1 for A, 1 for B, 1 for C, and 1 for D. Okay, so putting 3 seniors from North High School in a committee to plan an event. Alright, that is a combination because it doesn't matter what the order I chose those 3. So underneath my keywords for combinations, I would say pudding or a committee. Awarding identical ribbons to the first 2 finishers in a race. Okay, so since it has identical ribbons, identical prizes, the order doesn't matter. If you finish first or you finish second, you still have the same exact prize. So B is a combination. C, filling the positions of president and vice president from the members of the student council. This one matters because if you're chosen first, you're the president. If you're chosen second, you're the vice president. So in my keywords under permutations, I would say filling positions because situation C is a permutation. And then D, awarding gold, silver, and bronze medals to the first, second, and third place finishers in the race. That is a permutation because the order does matter. So situation D is a permutation because you're either awarded the gold, the silver, or the bronze. Versus situation B, they're identical ribbons. So that would be like awarding the first two finishers gold. They both won gold, whether they were first or second. This one, if you're first, you have the gold. If you're second, you have the silver. That makes a difference. Okay, great job. Question 2. Use the expression 5 choose 2 to answer the questions. Which expression correctly uses the combination formula to calculate 5 choose 2? And evaluate the expression you chose in part A. Alright, so if you notice, this is red. 5 choose 2. And so we have 5 choose 2 is equal to 5 factorial, our first number, divided by our second number, times whatever's left. So what's left between 5 and 2? So we're going to take 5 minus 2. So that would be our expression that correctly uses it. And we're going to simplify inside our parentheses. So we're going to have 2 factorial. What is 5 minus 2? That's 3 factorial. Since we have 2 factorial times 3 factorial, we're including parentheses. That is one group. So we have 5 factorial divided by parentheses 2 factorial, 3 factorial. Alright, and that's going to equal 10. Alright, so we're looking for just 5 factorial divided by 2 factorial times 5 minus 2 factorial. And then for B, it is 10. Submit for grading to make sure. And then question 1, which description most accurately matches the definition of the combination? An arrangement of beads on a necklace with a clasp. That's a linear, so, and does the order of that matter? Yes. A selection or listing of objects in which the order of the objects is not important, or a selection or listing of objects in which the order of the objects is important. An arrangement of objects on a key ring. Okay, 2 things. In the first one, they're using an arrangement, and the last one, they use arrangement. That's a key word for permutation. So those ones, to me, would be right off my list because they're using a keyword to describe a permutation. The second thing is, I would hope that I would have a definition for a combination written down in my notes. And if you did, it's the order of objects that is not important. So that is the definition of a combination. It's where it doesn't matter what order it's picked in. It's just picked. So good job.